Alright, so just a quick overview of what we've talked about in class. Operating with complex numbers. First operation is addition and subtraction. So the idea here is you add and subtract the real parts and you add and subtract the imaginary parts separately. So for example, if you have 8 take away 3i, and from that complex number you want to subtract negative 2 plus 4i, then you'll deal with the parts separately. So you deal with the real parts. 8 take away negative 2 is going to be positive 10, and then negative 3i take away 4i is going to be minus 7i. So a bit like algebra really. Real parts like terms, imaginary parts like terms, add and subtract them. Okay, so just having a quick look at multiplication of complex numbers. I'm going to use the distributive law, so I'm going to use that concept of FOIL or a similar one, but I will change the order of FOIL around. So I'll multiply it. 2 times 1 is 2. I'll then multiply these terms together to give me 6i squared. I'll then multiply 3 times the 1, so that's 3i, and 2 times 2i is 4i. The reason I change the order around is by doing so, by multiplying the first then the last, I actually managed to keep my real part together. I squared is negative 1, 2 take away 6 is negative 4, imaginary parts together, 7i. You notice that when I've multiplied these, I've got a complex number still. If I took something like 5 plus 4i, and I multiplied by what we call its conjugate, which is the same but with a negative in the middle, just like a conjugate surd. So 5 plus 4i times by 5 minus 4i, you'd recognise that as a difference of squares. So you should be able to say that's 5 squared minus 4i squared. So that's 25 take away 16i squared, which gives me I squared negative 1, 25 plus 16, so it gives me 41. So in general, if I take a complex number and I multiply by its conjugate, I end up with a squared plus b squared. When we're talking about division, we're talking about realising the denominator. And so we want to do that by multiplying by the conjugate to get a real number. So if I want to do something along the lines of 2 over 3 plus 4i, then I want to multiply by the conjugate of this, 3 minus 4i over 3 minus 4i. So we're taking this one straight out of the surds playbook, and so that's giving me 2 times all that is 6 minus 8i. On the denominator from the work I just did, I know it's going to be a squared, that's 9, plus b squared, 16. So I'm going to get 6 on 25 minus 8 on 25i.